Hello, great to be here, and yeah, we're really excited to be talking about this collaboration and how the collaboration ecosystem works here in New Zealand, using our two companies as a prime example. So I'm Ian Hosey, one of the founders and the CEO of Revolution Fibres. I'll briefly explain our company, what we do. So, as you can see on the stage, there's three pictures here, and this explains, I guess, in a nutshell, what our technology does. We're one of the global leaders in nanofiber production. So, looking up here, this is how we make fibers. We make nanofiber out of a range of materials. Could be polymers, biopolymers. We carry functional additives, and we do that by charging a polymer from a droplet and attracting it to a negative charge. So positive charge there, negative charge there, and effectively drawing a fiber out of a droplet. The process is called electrospinning, and we've got our own proprietary technique, which is mass production. So our technology has thousands of these droplets, continuously producing fiber in a high voltage field. What comes out are fibers that are 500 times thinner than a human hair, made of a wide range of materials. These materials have really high surface area, really high surface area. It's a platform technology. It's got so many uses, it's quite ridiculous. But effectively what we're doing is making very light non-woven fabrics, which are being used in composites, to cosmetics, filtration, and acoustics, which we'll explain more now. This is a typical textile that comes off our machine. This here is meters and meters long, but it's only 1 gram per square meter. So it's an incredibly dense, lightweight material, and that's what we make. Our business model is all about designing nanofiber products. We work with partners, with companies, and ourselves as well, working on finding uses for this technology. We develop superior products using the technology. Some of them we sell ourselves. More often than not now, we develop these technologies on behalf of our clients to get our technology into their supply chain. We manufacture what we design. That's why people work with us. They want to work with a manufacturer. Less so research providers, because effectively you'll get your prototypes, but then you have to figure out who's going to make it afterwards. And more often than not, we partner in the commercialization aspect as well. So we are actively trying to sell the products that have our technology in it. Here's some examples. On this side of the screen, we have air filtration. We sell into ventilation systems, HVAC, and face masks. Active layer, big seller for us. This is a collagen nanofiber, which is used in anti-aging and is working towards medical devices. So this fiber dissolves rapidly into the skin, delivering nutrients into the skin. It's a great product, being launched in China at the moment at the Shanghai Beauty Fair. Xantulayer is used in resin to support carbon fiber structures. Phonics is the acoustics. We'll explain more about that soon. And we also have a range of anti-allergy bedding to keep dust mites out of asthmatic children's pillows, for example. So incredibly diverse uses, and all made and sold by us. This is one of our machines. This is the Komodo. We designed and developed that in 2012. We've been producing nanofiber commercially since 2013. As I said, there's a range of products. And we've just built a machine that's being commissioned right now, which will be 4 times the production of that, probably the largest spinning machine in the world, and that will just be making collagen fiber. So that's us. Pass it over to Matt to explain his great company.
Thanks, Ian. So my name's Matt Rowe, and I'm the Managing Director of Daschles Technologies. And our company was formed to basically take the drone out of drones. And we were formed around a competition that Callaghan Innovation ran in 2015. And they identified a number of challenges with cinematography using drones. A lot of films produced in New Zealand, as we all know. And one of those challenges was noise. Issues, obviously, noise on set and post-production, and the cinematographers just accept that drones are noisy, which they are, incredibly noisy. And we thought that that was probably the biggest challenge facing not just the cinematography industry, but drones in general, as drones emerged as a market, into different market sectors. And so in 2015, we sat around and thought, well, how does the aircraft industry solve that problem? Well, the aircraft industry has been solving that problem since essentially 1965, when aircraft were ridiculously noisy, and now they're still noisy, but they're a lot quieter. And we thought, well, let's look at some of the technologies that they're looking at. And one of those is acoustic composites and materials around the jet engines. And so we thought, well, who's making those for drones? Well, no one really was. And so we reached out to Ian and saw that they're making this acoustic nanomaterial, which was incredibly lightweight. And of course, with drones, you don't have a lot of weight to play with. One of the issues with drones is flight time. Obviously, you can't add a lot of weight to that. So we looked into Revolution Fibers and started to access some nanomaterial that she provided us. So that's sort of where we started from 2015. So that was really around market concept. And then last year was really around intensive R&D. So just looking at, obviously UAVs are incredibly loud. Uber just last week, was it a week ago, held a what they call the Uber Elevate conference. And one of the issues that they see with their people-moving drones, which right now isn't even a market, a lot of people talking about it, but one of those issues with urban mobility is noise. So they're looking for technology solutions, a lot of tools and things like that. And we've been around, obviously, 2015, focused solely on noise, and also enabling audio, which I won't go into too much today, but we're solving those two problems. And a lot of industries are emerging that require these solutions to access those markets. So they come up against noise as an issue, and it's incredibly technically challenging to solve. So then they end up reaching out to people with solutions that will solve those problems. For instance, security and defense, we have customers in cinematography, and we have quite niche applications with audio inspection using drones as well. So we're getting a whole bunch of different people reaching out to us for our solutions, and one of those things underpinning it is a lightweight acoustic composite, which is using the phonics. So yes, we're going on. So the solutions that we're developing basically are acoustic shrouds which encase the propellers and composite the nanomaterial and reduce a number of the different tones, soaking up the sound using the materials and composites we're developing. We're also developing low noise propellers, and we've also got an active audio solution as well, where we've actually got microphones on board and picking up a signal, filtering out whatever remaining noise is on board, and then transmitting that down to a base station. So that's a hardware-software solution. The rest is materials, design, composites. So research partnerships for us are incredibly key. We don't know anything about making nanomaterials, so we rely on Ian and his team to produce nanomaterials for us. But what we do is we bring a market focus to our customers into the drone industry. And the drone industry is enormously, it's disrupting itself as it scales right now. And so we've brought together a partnership with Revolution Fibers, which underpins everything. It's gone back to 2015. We've got a partnership with University of Auckland, where we access world-class acoustic testing facilities right here in Auckland, some of the best in the Southern Hemisphere. We're bringing in top aerospace talent from Boston to MIT to work with us. And we've also got R&D contracts, grants, and things like that from Callaghan Innovation, where we're developing technology through another anechoic room down in Wellington. So we're bringing together a whole raft of expertise to solve these issues for our customers in the drone market. So is that back to you, Ian?
So when we were asked to talk about collaboration, we as a business, we created a whole bunch of products trying to be at the forefront of the market. So we made a filter product, we made a cosmetic product, we made a composite reinforcement product. And every time the phone rang, it was for something different. So we kind of had to either pick a couple of markets or embrace the fact that we had a platform technology. And the way to embrace platform technology, I believe, is through non-recurring engineering. So people see us as sector experts. We're not people who can sell cosmetics. We don't even design cosmetics. But we can offer our technology to the cosmetics market. Same for acoustics. We don't know anything about drones. We're starting to understand a bit more about them now. But it all comes from partnership. So we're attracting people who recognize that they need this technology. They recognize that they need to work with sector specialists. They need to work with manufacturers. But these partnerships are what's key. Now, these partnerships, they do cost money. They cost us money. Quite often we do stuff for in-kind contribution. Sometimes we want to be funded. It could be an external funding body. But whatever the case, we create these partnerships, and this is then we go on that journey of refining the product again and again and again. There's been huge amounts of refinement with Dotterel. But then we have a product that we can we've co-innovated, we've created together. And it doesn't matter what that market is then. We can collaborate just as readily in the healthcare space as we can in drone technology, because we're focusing on our technology, we're focusing on our platform. So this model here has been working really well for us. It's opened up quite a lot of partnerships. It's about 25% of our income, and it's allowing us to be, you know, the top part of the pyramid of the next niche applications for nanofiber.
So when we reached out to Ian with his acoustic composite, I think it was used primarily in, was it for fabrics or?
Yeah, in acoustics, it was used in office furniture.
Yeah. So obviously putting a flying chair up in the air wasn't really what we were after. So we've done a lot of development, tuning that nanofiber through to specifically for drones make a lot of tonal noise. So we're targeting a lot of the tonal noise to take the tones out. A NASA study just recently, it was about 6 months ago, found that drones are the most annoying vehicle on the planet, and it was because of the tones. It's quite loud and screechy and whiny. So the materials that we're developing with Ian are specifically targeted to take some of those tones out. It's obviously technically challenging, but we've made quite good progress with that. So, and so basically we've taken that material, we've incorporated into a UAV. And this is a small drone that we have prototyped up for a trade show. Part of our strategy is obviously getting in front of our customers. So we've been to a number of big trade shows over the years. We were up at CES just this year, showcasing our small UAV with the shrouds on. And you'll see this in the background. We're filming it on Friday. There's just off an iPhone, so haven't got the full footage. But it's basically our drone in the distance blending into the background because we've taken the tones out, and another drone, which is a DJI Phantom, has been filming it, and you'll hear the Phantom coming in, and then you'll hear some reactions at the end there. So we'll just go through that right now. Let's see. So there's our drone up in the background there, and there's the Phantom going in.
That's just ridiculous.
Yeah. Can't hear it, eh?
Right. Like that's, oh my God.
So I thought those reactions were pretty cool. We've got another video coming up in the Q&A, but it's been a really amazing journey for us. We actually got into a lot of obviously security and defence applications potentially for, as you can probably tell. We got into a Techstars program last year over in Adelaide. Adelaide's the bottom of Australia, defensible harbour, and that was around defence. So we're actually mentored by a number of big defence contract companies, Boeing and Thales and Saab and all that. And so those markets are opening up for us, but they are quite slow moving. But I think we'll have some pretty exciting news coming in that area soon. So, yeah. Cool.
No, that's just get that. Thank you very much indeed, Matt and Ian. Now, you're probably wondering, audience, how I exited stage left and turned up stage right. Actually, I was stood here the whole time because Ian had spun me in an invisibility cloak with his nanofibers, and I was right there, shoulder to shoulder. It was quite fantastic. Sorry, it's terrible. I joke. Come this way, and we'll do something serious.
You can see a shadow.
Yeah. What was the shadow that gives you away? Yeah. Let me just start with your passions. What is it about drones, Matt, that just you kind of locked onto them as the thing you wanted to do?
It sort of fell into my lap, really. I mean, my background is actually chemical materials engineering. I did a decade with global gas fermentation leader Lanzatech. So at the end of that project, obviously they moved up to Chicago for commercialization. But drones, it really came about that competition. They identified these three challenges, and I thought, well, noise has to be a big problem. And if there's a big problem, there's got to be some value in there. Yes. So really, our team sat around and thought about how we solved that, and it's really just been a journey since then. Yes. So it was not really. But prior to that, I'd never flown a drone at all. So it's more about solving a big problem, I think, and understanding that the market, as it emerged, it becomes self-fulfilling with drones with noise. So that's what we predicted, and we're starting to see that happen now.
Yeah. And so your science background, given the Lanzatech, was around biology or physics or chemistry?
Yeah, so I started in by obviously the fermentation process. So it's some pretty exciting news coming up with that company. But it was all around fermentation. But my role really moved into R&D operations. We had a big team by the end, 150 staff. So we were really executing. So it's building out plants, transferring technology, and that's part of the scale-up process. So it's really where my passion lies now, is taking things from nothing to something.
Yeah, well, fantastic expertise and skill to have, talent to have. And Ian, yourself, what is it about nanofibers and creating these amazing electro-spinning machines that...
Yeah, well, ours was a little different. I guess I was working at HRV, which was a company doing really well in New Zealand. It was the fastest growing company in New Zealand at the time, 2007. And that had a bit of a conundrum because everybody saw these ventilation systems as a condensation control device, or even like pseudo heaters. And HRV really saw it as a health product. And in doing so, we decided that we wanted to have the best filter in the world. And that was the best way to actually do it, to really just say, look, this is the best filter. So I started looking at technologies, but there was a real technical challenge in the sense that we didn't want a big, noisy, energy-sucking fan up in people's roof spaces. So we really had to look at technologies that we could filter a huge amount of particles but not put pressure on a fan. And nanofiber shrunk the size of the fibers, and therefore we had small holes capturing all our particles, but we also had small fibers. So we got into the market, we understood the technology, we had scale to get into. We had to get 100,000 square meters a year just to get started. And that was where the big challenge started. We couldn't buy it. We didn't know where to buy it from. We couldn't get it changed and manipulated how we wanted it. So we decided to become manufacturers ourselves because we were a target audience. We wanted the technology. No one was making it. And the more I investigated it, the bigger the market seemed. So, and the big gap was manufacturers. So I guess that gave us the incentive to build the machines. It was a classic case of build it and they will come.
Yeah. The two of you are just sort of classic examples of New Zealanders who kind of go, oh yeah, no, I think we should have a go at that. I mean, there's something to be done there.
Yeah.
And I must just reflect on a little bit of history for you, Matt, because you're obviously up at, I know that Daschles based up at Balfour Road in the old IRL building, Callaghan. And it's really a living monument to New Zealand technology because LanzaTech, of course, had its big start there. Rocket Labs is still there.
Yeah, well, it's an amazing facility. I mean, it's another hat that I wear off and on. But we've got about 3,000 square meters of innovation space there. And as you say, LanzaTech they occupied about 1,500 before they relocated to Chicago. That was my role before I left, to relocate them. And since they've left, a whole bunch of new companies have come through and leveraged the facilities and access to the informal networks of investors and talent and how to get things done in a deep technology sense. It's quite different when you're like Avatana, for example, which is the largest tenant on site right now. I mean, they're dissolving things with sulfuric acid. You want to do that in your basement? Probably not. But we've got it's the I guess putting the big boy pants on. You need insurances and health and all the big stuff. Peter Beck was based there for a number of years, and it's enabled Dotterell to grow. And I guess we're really excited for the future for that. We're having an event tomorrow where we've got a clean tech update. So we've got Mint Innovation, Avatana, and Sean Simpson from LanzaTech will be video linking in to give an update on clean tech tomorrow night.
Fantastic. Yeah. And so is there a real sense of the sort of the whakapapa of the R&D that's gone on there that is carried through and there is knowledge that's passed on?
Yeah, it's really funny you should ask because it's all quite private collegial, I think. Everyone's got their own space in general. But we've noticed over the last, just for Dotterell, we've gone from literally a cupboard the size of these 3 couches through to probably about 100 square meters. And we find that everyone's borrowing stuff off us now and asking us for help. So it's that sort of thing that happens. And being around other companies solving big problems, raising money, like serious money, and getting out there. Like some people aren't there for months on end. They're out, trade shows and raising capital or whatever they're doing, But they always come back, I guess, home, and then eventually they expand over. Obviously, LanzaTech moved to Chicago for capital and technology reasons or whatever the reasons, and then Rocket Labs moved out to much bigger facilities, and that provides the next version of companies. So, yeah.
Yes, and crucially with the technologies that you're using, that's a very powerful argument for having a research and incubation space like that, which is around those sorts of technologies. Software and something fairly easy to do those kind of buildings, but it sounds as there's a really good case to drive technologies like yours in specialized facilities like that.
And we'll be announcing some pretty exciting news tomorrow night for that. So
I'm very eager, especially around clean technology. Really tremendous. And in terms of close proximity, though, with you in Parnell and you are out in Henderson with your company, is that close proximity, physical proximity, useful and important to you?
Yeah, absolutely. For us, we collaborate with companies all over the world, Europe, USA, Asia as well. And they're great partnerships, they're great collaborations, but they're never as easy as the ones who are just down the road. You know, I think like the face-to-face interaction, getting engineers on your team to talk to engineers is, you know, all the problems are just talk direct, engineer to engineer, not through a business development manager or through the CEO. So it's really easy to collaborate and actually get refinement of technologies. And I think that's something we really want to encourage. There's a lot of startup companies, there's a lot of uses for our technology in New Zealand, and I think New Zealand companies have perhaps the best shot of commercialising or being first to market with our types of technology just by the ease of collaboration, face to face.
So then when you are interacting with people overseas, you then sort of slipping into a kind of a different mode. So you've got sort of various ways of working that vary with the distance.
Yep, absolutely. I think when you're collaborating overseas, it becomes a lot more contractual. There's a lot more stage gate. There's a lot more milestones, a lot more reporting. A lot of it's a bit more of a formal relationship, I guess, where sometimes we catch up on Friday and have a beer together, and we download how things are going, and that's the meeting. And it's a much better way of doing business. We can't do it all the time, but it is effectively the same information is getting portrayed in a much more congenial way, I guess.
I mean, getting out there and obviously the close proximity is fantastic, but you've got to, for your customers, you've got to get out and be with them, you know. So we have no hesitation getting on a plane for a meeting and being there. You just have to do it. So, but the other thing is attracting people down to New Zealand to meet with you works as well. So it's not a hard place to get people to come down. I mean, our partnership with Boston, we've got their top aerospace candidates coming down to work with us. That was an easy sell. I think we've got the cream of the crop this year, literally. So, you know, you want to come down and work in New Zealand? Yeah, sure. So there's a lot of that as well. And we've also been quite lucky. Our family's got quite deep aerospace connections. We've got incredible support from Air New Zealand, which has enabled us to get places. And we've got a project coming up with them in the near future as well.
That's really interesting because I know Air New Zealand's mindset is very much about, yes, it needs to be really good at being an airline, but it's also amazingly innovative in terms of how it organizes itself. So it can operate a very complex business in a very flexible way. So can you tell us a little bit more about the relationship with Air New Zealand, or is that still...
Well, my father is, he's done, I think, 50 years at Air New Zealand, so he built all the jet engine test cells where they test all the engines for all the planes in this country. So he was responsible for that.
So this is a family that takes noise seriously.
Yeah, well, exactly. And then, so obviously he's got great respect with Air New Zealand, and we've got partnership right to the top. So we've got a marketing and agreement with Air New Zealand, and that helps us with flights, and we've got a project coming up with them in the very near future where we're displaying some of our technology within their operations. So that's pretty exciting. So
it's
really exciting
to see them playing that role.
Yeah.
Ian, there's a number of questions coming through, for example, from David and one on the webcast about in your business, there's clearly so many potential applications, and how you sort of prioritize them so you don't sort of find yourself spread far too thin.
It's a classic. What we found once we had our machines operational and running, we'd already had 2 products in market, and we had about another 10 ideas. It was a bit ridiculous. So we were suffering for what we called excessive opportunity syndrome. Yeah. And we were just running around like headless chickens trying to develop multiple products at once. And as I mentioned in the presentation, the market was always wanting something different or a slight tweak on what we had. So we had two choices. It was ignore the market and just pick a couple of applications, and that's what most nanofiber companies or most textiles companies have done, is just pick a market, stick to it. And that was all the advice we were getting from potential investors and funders was exactly that. But they weren't listening to the market like we were. The market was telling us that we just want rolled goods. We want a textile that is doing what we want. And so we had to just respond to the market. And the way to do that was through non-recurring engineering. We weren't trying to take ownership in anybody else's markets or technologies. We weren't trying to compete with anyone. We were sticking to what we were good at, which was making nanofiber. And that has worked really well. That we've got some really great partnerships now that continue to build year on year on year, just through that sort of model.
And as a kind of a follow-on question here, again, it's a webcast question, asking what's your dream application? What's the one that just seems a most extraordinary challenge?
Look, I believe the killer app for nanofiber, it hasn't been discovered yet. There's thousands of papers a year come out with our technology. It's really, really exciting that the research community is just discovering more and more uses for nanofiber, while we just sit there and just collect the papers and think, well, this is great, this is going to be fantastic. Yeah. And we try and connect the dots with industry. Yeah. I believe acoustics is one of those areas, especially as we miniaturize our electronic devices. Your typical technologies like foams and fabrics, they're obsolete. We have to absorb sound with thinner, more lightweight materials. And that goes everything from headsets, microphones, the lining of vehicles. It's huge. So I reckon that's got huge potential, and I think we're in one of the best spaces now with active layer. If you get a chance to see our technology just dissolve into the skin with 100% natural collagen carrying nutrients into the skin, which can be drug compounds. This is a new way of delivering topical skin applications. It's huge. So I think that technology is one that we're really passionate about and we see a huge scope for.
So almost anything where a membrane's involved of some kind.
Yeah.
A nanoscale.
Yeah, we're effectively bridging the gap between non-wovens and membrane technologies. So yeah, we're working anywhere we traditionally would have used Gore-Tex or a polypropylene, polyester layer, just shrinking it all down.
Yeah. I realise, though, you may not realise this, that you've got some competition from the hemp industry in acoustics. No, it's not a question of smoking and just chilling out. But, for example, I sort of fact I pick up, a C-Class Mercedes-Benz has 20 kilograms of sound-deadening material there made from hemp. Yep. So I'm not sure most Mercedes-Benz owners realise that, but so you've got a competition coming at you from some kind of
I believe like let's say it's 20 grams per square meter material that they're using, for example. Yeah. We can shrink that. We could use it to half that weight by putting 1 gram of nanofiber on top of 10 grams of hemp. All of a sudden, you're going to probably exceed the acoustic performance. So a lot of these materials, they still need something fibrous in between two linings to give it structure, to give it some some weight, and also some frequencies, like the bass end, they do require something a little heavier, a little denser. But we can effectively, with a small, very lightweight membrane that will do nothing to the weight, increase its broad range of frequencies.
And that's the primary reason we're using it, for weight and thickness. So.
Yes, and actually, coming back to the question of the acoustic work you're doing, I've got a wonderful question here from Peter. Is the greatest risk to drone industry the public access Joe Public has to drones, and the chances of a public backlash to accidents and privacy issues?
For sure, it's definitely an emerging issue as they become more prevalent. I think the regulatory bodies are struggling with that around the world at the moment, and they're setting guidelines for that. And I guess what will occur is those regulations will become more stringent if things happen like that. There's already, I mean, you already can't fly them over people's houses right now without permission. Doesn't stop people from doing it, but there's a number of those coming, and they will. The technology on board will probably start to restrict them from doing those things as well. So there's a lot of work going into. I mean, noise is an issue, but there's other issues, big issues as well, like air traffic control, obviously, of drones and how they integrate into the airspace. There's some very large companies working on those issues as we speak, especially around urban environments. So
and and I think we've got something innovative going on in sort of air traffic control for drones.
Yes.
Can you just describe that?
Off the top of my head, I believe there's a partnership that's been formed with a couple of big aerospace companies here in New Zealand that's looking at that issue at the moment, and you've got some things being tested with the Zephyr drone down in Christchurch as well. Yeah. So there's some really cool stuff. In New Zealand, I think Peter Beck mentioned about you're only one conversation away from meeting with the regulatory bodies here in New Zealand, so you can start to really play a part in that down in New Zealand. Yeah. And to date, the New Zealand regulatory body's taken a very pragmatic approach to UAVs. There's a number of air spaces that are open for testing, and the legislation at the moment is quite open as it stands at the moment. So,
some of the same sort of ethos that we were talking about with Peter earlier about space regulation.
Potentially, I mean, New Zealand's got an opportunity to become the UAV testing ground for the world. I mean, this is an exciting future for aerospace for New Zealand. When if you look back at aerospace, we're some of the founding pioneers of aircraft. So potentially we can play a big role in that going forward, and I think we're on the cusp of that, and I'm quite excited to be part of that journey, really.
Yes. Now, a noise cancelling question. Can you also do something about jet skis?
I wouldn't mind a jet ski, so had some
David
time.
asked.
We get asked that all the time, because obviously we're developing technologies that reduce noise and enable audio. Those technologies can be applied to other industries. What we're really focusing on is executing with our customers within markets at the moment, within the drone space. So that's really our focus. That's big enough already, and as Ian mentioned before, you've got all these people coming at you. You've got to pick where you think is going to be the lead to the next part of the journey. So we were up at CES just this year, and fan noise and all sorts of things. But yes, jet skis, incredibly noisy. I don't know, maybe.
That's right.
I'm sure we can, but
now,
probably not this year.
Now, I know we've got another great second clip to watch and to listen to. Yep. Can you just, before we start the clip, just talk us through what we're seeing here, because it's a real insight to the nature of your technology. Yeah,
so the clip you saw before is obviously a drone's in the distance a little bit, blending in. We've taken out a lot of the tonal noises with that particular drone and that iteration. And in this clip, a lot of companies put on what they call safety cages on their drones for various reasons. Obviously, you don't want to, once you start playing with the big stuff, you don't want them hitting you. But as you put things around rotors, you start to generate noise. So this clip here is just an example of a drone with some safety cages on that are a consumer off-the-shelf product. Then it's just without them. Actually, that's without them first, then with the cages, and then with our shrouds on with the Nanofiber, taking out some of the tones. So it's a lot closer, there's a lot more noise, but you can hopefully be able to hear the difference here.
That'd be great. Thank you.
Oh, it's really quiet. No, there's no audio on that.
Yeah.
At all.
No.
Something's going wrong.
We'll see if it suddenly starts. Yeah. This is really impressive.
That's incredibly impressive.
I see you've cracked the technology here.
This is another challenge with audio tech, is it sometimes goes.
Yeah. Maybe we could hum.
Yeah. So, actually, this would be really. No, I won't put you to this test. You can sort of try and reenact this. I'm just going to ask the tech desk if it's worth having another try.
It was working yesterday.
It was fantastic, wasn't it? I'm sorry you weren't here last night. It was fantastic. Is it worth another try? Do you think you can? Fantastic. Oh, this sounds good. Well, that's very impressive. Yeah, I think. Thanks.
So you can tell the decibel difference between the first and the third is about 3, but the tonal makes the big difference.
The tone thing is
it's
quite
more
fascinating,
of a hum. It's
isn't it?
broadband noise.
You could kind of live with that because it's not sort of shrill and sharp.
Yeah, a lot of in the industry, silence is being able to blend into the background noise. So obviously, background noise here is probably 40, 50 decibels. So
yes.
you're getting down lower to that, you can blend in. So.
Yeah, and I'm very interested in from the nanofiber point of view about how different fibers cancel out different tones, and therefore you can sort of artistically, weave the right composition.
It's been amazing. I mean, like, we've never really had the opportunity to work on such a broad range of frequencies. Usually a client will say, look, it's the 1,000 hertz to 2,000 hertz is our problem area. Can you enhance that acoustic absorbance? And when you talk to Matt, it's the problem's from 0 to 20,000 hertz. It's across the board and they're all loud. Yeah. And so we've had the opportunity to try different polymers, different ways in which we can enhance the acoustic fabric. We bring other functional additives into the web that we're creating in order to just shift the peaks of quite a broad spectrum profile, acoustic profile. So it's actually quite a combination of polymers and technologies that we've got in here, and I mean it's a challenge. It's the sort of thing that we love, but yeah, and it's actually allowed us to push our technology a lot further than we expected to have to go to in acoustics.
Yeah. So this drone here is about 6-inch propellers, and what we're doing right now, that was built about 4 or 5 months ago now. As a prototype MVP, when you want to call it, minimal viable product. And what we're doing right now is actually scaling that up, and that's pretty exciting. So going from little to almost 3 foot,
Big noise, big silence.
Well, as the drones get bigger, the noise changes. So so that they are louder, they're carrying more. But they're also making different noises as they scale. So we're building those technologies at the moment.
Yeah. And we're quite fortunate that once we understand the profile, we can shift our materials. And we've got a good understanding now from 2 years of R&D to say, with that drone, this will be the right nanofiber combination.
Yeah.
Wow.
Yeah.
I just have to make another connection. I may be drawing a very long bow here about trans-Pacific flights. I'm obviously completely obsessed about them. And to me, the greatest thing is noise-cancelling headphones. And presumably that's, and we have had some companies, I'm sorry, I've kind of lost track of them here in New Zealand, who are really good at that. So that's actually a crucial part of this.
We've mainly talked today about the passive technology, so obviously we're incorporating materials. We're also a lot of design going into that. There's design, propellers, ducts, all sorts of things there. The other part of our business is audio technology. So putting audio on board, you think, why do you want to do that? Well, there's a number of applications that people reach out for us to put audio on board to come in and pick up an audio stream. Obviously, that's challenging with all the noise that's already there. We can get rid of some of it, obviously. But we've got an algorithm, basically, that we've working with the University of Auckland on. That technology's come out of there, and that's an onboard hardware, software solution that is a microphone array, picks up an audio signal, processes out, essentially like a headphone, and then gives you a clean audio signal of that particular. Yeah, so that I haven't shown that today, but that's another partnership that we have and working on. And the passive technology enhances that as well, right? So obviously the lower the drone noise, unless you have to filter out, it all works in combination.
A virtually silent drone is possible.
I wouldn't say, well, as I said before, it's about your context of what you call silence. But our goal is to be the industry leader in solutions to reduce noise. And enable audio. So.
Speaking personally, I think I'd like to have a little audio clue that's a drone.
We've got the electric cars, right? They actually put the sound in them so you can hear them. So.
Yeah. Ian, a really good question here before we close, and I know I'm right up against the limits time-wise, but it's a really important one. How is nano waste tracked and retrieved, and how is it impacting environments?
Nano waste?
Yes. Nanofiber waste.
Oh, nanofiber waste. That's an interesting question. We typically use non-hazardous polymers, and in the nanofiber form, they're incredibly biodegradable. I mean, we're talking 500 times thinner than human hair. So we're getting huge performance out of ultra lightweight fabrics. So for us, we're waste minimization, just as the nature of shrinking textiles to a fraction of what their typical size is. We don't. I mean, we're just basically we're a plastic manufacturer in miniature, if you like. So yeah, not really quite sure how to answer it apart from look, you know, nanomaterials, just like any technology, they need to be well regulated, but there also needs to be a curb on, I guess, what we would call nano fear. You need to look at these technologies and actually say, well, they're non-hazardous in a macro form. There's no way they can actually change their toxicity in a micro form. Some do, and they're quite well understood. And we're just trying to be careful about the materials we use and make sure they're relevant to the application. So obviously for skincare, we're treating this with a huge amount of respect.
Yes, yeah.
But in the drone, it's really about what's right, what's making the technology work.
Yeah.
Yeah.
Look, thank you. Very big hand, please, for Matt and Ian. Thanks.